Hi everybody, Dan Hewitt here, and you're joining us at Chamber A. It's a historic landmark. It's one of the largest vacuum chambers in the world. I'm joined right now by Mary Saramelli, the lab manager of this facility. Mary, thanks so much for being here today.
No problem,
Yeah.
It's great.
So first off, real quick, give us a little history about this chamber. I mean, it's huge, it's large. What's it been through? What's it here for?
It was built in the early 1960s and mid-1960s to test the Apollo spacecraft that went all the way from low Earth orbit to the moon. So that's why it's so large, because that was a fairly large spacecraft that needed a lot of room to be able to experience the full thermal and vacuum environment of space.
And it's been getting a lot of upgrades lately because
Yes.
What have you guys used the chamber for in the past?
In the past, we've used it for mostly things that were too big to be tested in smaller chambers, such as the large payload bay radiators for space shuttle, or the radiators for space station, the thermal system for space station. Also vehicle size things like the Beagle lander airbag system that went to Mars. We've also used it for some movie making too. Armageddon, Future World.
So it's definitely a little famous.
Yes, it's our resident diva.
Okay. Now upgrades. What are some of the upgrades you guys are making? Major infrastructure upgrades to this chamber. What are some of them?
We've made several major infrastructure upgrades over the last 4 years to make this chamber clean enough to test an optical telescope, as well as make it cold enough. Those were the two major goals we needed to have. Originally, the chamber could go to about minus 300 degrees Fahrenheit, but in order to test the James Webb Space Telescope, we needed it to operate around minus 440 degrees Fahrenheit. Much colder than any other chamber on the planet of this size. So this is new technology, this is a new concept in the world for being able to get something this size, that cold, and keep it there for 90 days while we're testing.
Like you mentioned, you're going to be testing the James Webb Space Telescope. What is it?
The James Webb Space Telescope is the next Hubble. It's the next greatest thing in infrared space telescopes. It's going to launch in 2018, and it will not orbit the Earth as we think of most of our telescopes and other satellites. It's actually going to go 1 million miles from Earth, 4 times farther away than the moon is from us, and hang out at the L2 Lagrange point, where at that point, that's why it's so cold. It's very, very cold at that point since we're so far from the influence of the Earth and the moon, and it will be able to look for the most faint sources of light as close to the Big Bang as we can get.
Why do we need to put something like James Webb in a chamber like this?
Oh, well, James Webb is breaking new ground on all its technologies, on its materials technologies and its sensor technologies. All of these things need to be tested out before we launch it off to Earth, because once it gets out to the L2 point, we're not getting it back, we're not be able to service it, refuel it.
We're not going to be able to jump up there and repair it.
We're not going to be able to repair it, so it's got to work before we launch it. So we have to fully test out all the systems, the way it will operate on the ground here where it's cheap and easy to do.
So the inside of that chamber is basically going to be like what James Webb is going to live in when it's 1 million miles away.
That's right. It looks very unassuming. It looks very black. That's what the James Webb Telescope is going to be looking at, is a lot of black and searching for very faint sources of light amongst that black. And it's going to be very, very cold.
And what are just some of the general tests you guys are going to be running on the telescope once it's inside?
Once it's inside, we're going to be exercising the infrared sensors. We're going to be seeing what the mirror assemblies do when they're all exposed together at the same time to the cold environment. So far they've been tested individually. We're going to test all 18 mirror segments together and make sure that the mechanics and the electronics all work the way they're supposed to before it flies. This is one of the last tests of all the systems on the James Webb Telescope before it leaves to go to its launch site. So it's the last place where everything will be together to test.
So last stop, last chance, very important. Get it ready before it goes.
Very important, because it will launch less than a year later after it leaves here from French Guiana.
Okay.
Yeah.
All right, well, fascinating. Again, cavernous, historic chamber. You guys are doing some amazing work out here. Thanks for giving us an inside look real quick. Really appreciate it. And if you want to find out more about the James Webb Space Telescope or facilities like this, can always look it up online at jwst.nasa.gov.